So hello friends, welcome back to my channel. So in today's video I am going to explain J Advanced 2022 Part 1 question, so that is physics. Let us solve it. So in my last video I solved 9 questions, I think so. Let's come to the 9th question. Yes, 9th question we have solved in my last video. So let us start from 10th question now. So here in 10th question they asked, the figure shows a circuit having 8 resistance of 1 ohm each. So here in this figure that they are given, it is having, in this circuit figure, it is having 8 resistance of 1 ohm each. 1 ohm each, 8 resistance are there. They are labeled as R1 to R8, they are labels they have given, resistance label. And 2 ideal batteries with voltage E1 12 volt, E2 6 volt. So here E1 we can see near R3, that is 6 volt it is having voltage battery, and E1 the first battery it is having 12 volt battery. The question they have asked is, which of the following statements are correct? The statements that they have given in this, which one is correct? The magnitude of current flowing through R1 is 7.2 ampere. The magnitude of current flowing through R2 is 1.2 ampere. The magnitude of current flowing through R3 is 4.8 ampere. The magnitude of current flowing through R5 is 2.4 ampere. So which one is correct we have to find. So first let us take first one. R1, R2, this let us make like this diagram. So point A, B are the some potentials, so they can be merged. So A, B it is opposite potentials, they can be merged we have taken. So like this it will become after merging. So for looping 1, minus 1 by 2 into 1 by 2 into x plus y minus x plus 6 is equal to 0. So minus 2x minus y by 2 is equal to minus 6. So therefore 4x minus y is equal to minus 12. So removing all minus, we will get 4x plus y is equal to 12. This is for first loop. So for second loop, 1 by 2y plus 1y plus 12 plus 1 by 2 into x plus y. Here the values again that we are doing. 3 by 2y plus y by 2 plus x by 2 is equal to minus 12. So 2y plus x by 2 is equal to minus 12. So 4y plus x is equal to minus 24. So 4y plus x minus 16x minus 4y. So therefore that is equal to minus 24 minus 48. So minus 15x is equal to minus 72. So therefore x is equal to 72 by 15. Now after that 4, if we take x, we got 72 by 15. Now let us put that to this equation, the first equation, this equation. So 4x x we have got value. So 4 into 72 by 15 plus y is equal to 12. So therefore y is equal to 12 minus 15 into 4. So 15 into 72 into 4 by 15. If we do, then if we take this to this side, 12 side, opposite 12 side, so y is equal to 12 minus 288 by 15. So 180 minus 288 by 15, that is minus 108 by 15, that is equal to 7.2 ampere is the answer we'll get. So current R1 is equal to 7 minus it is there. If we do cancel it, we will get plus. So therefore R1 is equal to 7.2 ampere. Now R2 same value, x plus y is equal to x plus y by 2, that is equal to 72 by 15 minus 108 by 15 into 1 by 2. That is 1 by 2 into 36 by 15. 36 by 15, that is equal to 2.4 by 2 ampere. 1.2 ampere will get. R3 is x is equal to 4.8 ampere will get. 1 by 2 into x value we have got, if we 72 15, here x value we have got, that if we do, we'll get 2.4 ampere is the answer we'll get. Right, 2.4 ampere is the answer we'll get. So here all the options, option 1 they are given, R1 is 7.2 ampere, R2 is 1.2 ampere, and the magnitude of the current flowing through R3 is 4 ampere, and the magnitude of current flowing through R5 is 2.4 ampere they are given. So we got all the answer as correct. So the answer for this question number 10 is all about means A, B, C, D, all we have to write. Okay, now moving on to our next question, that is question number 11. So in question number 11, here they have asked an ideal gas of density P is equal to 0.2 kg meter per cube. It enters a chimney of height h. It enters a chimney, that height is h, we don't know what is the height, at the rate of A is equal to 0.8 kg. At the rate of A is equal to 0.8 kg from its lower end and escape through the upper end as shown in the figure, as they have given in this figure, like that from lowercase a1 here it comes, and here the ideal gas it goes from the upper one, that is A2. The cross-sectional area of lower end is A1, that value is 0.1 meter square, this cross-section, and upper is 0.4 meter square, the value. The pressure and the temperature of the gas at the lower end are 600 Pascal and 300 Kelvin is the pressure and the temperature. Now, respectively, the temperature at the upper end is 150 Kelvin. At the upper end, the temperature is 150 Kelvin. Now, the chimney is heat insulated. The chimney is heat insulated so that the gas undergoes adiabatic expansion. So, we have to take G is equal to 10 m square, and the ratio of specific heats of the gas is 2. So therefore we have to ignore atomic pressure. Now the options they have given is the pressure of the gas at the upper end of the chimney is 300 Pascal. The velocity of the gas at the lower end of the chimney is 40 meter per second and upper end is 20 meter per second. The height of the chimney is 590 meter. The density of the gas at the upper end is 0.05 kg. So now formula that we are using is P1 by P2 is equal to temperature T1, pressure E1 by pressure 2 is equal to temperature 1 by temperature 2 to the power 1 by 1 y minus 1, that is 2 minus 1, it will be 1 only. P2 is equal to 0.2, here we have got P2 is 0.2, the ideal density means pressure, into 1 by 50 by 300 temperature there they have given, so 1 by 50 by 300 into to the power 1 by 1. So after dividing all this, we will get multiplication after we do, we'll get 0.1 kilogram meter cube. So the rate of mass flow here is 0.8 kgs. Now the volume flow rate at top is 8 meter cube. Okay, volume flow rate at the top is 8 meter cube. P2 by P1 is equal to P2 by P1 to the power mu, that is equal to P2 is equal to 600. Here 600 we have got Pascal. P is P2 is equal to 600 into 1 by 2, pressure is 1, P1 is 2, so 1 by 2, that is equal to P2 is equal to 150 Pascal. Now velocity of the gas of at the lower end is value means formula is V1 by A1, that is equal to 0.8 by 0.2 into 0.1, that is equal to 40 meter per second. Velocity of gas at upper end is equal to 0.8 into 2 by 0.2 into 0.4, that is equal to we will get 20 meter per second. So now by applying the energy conversion formula, that is 1 by 2 P1 into V1 whole square plus P1 is equal to 1 by 2 P2 V2 whole to the power square V square plus P2 plus P2, that is Pascal, into GH2. So 1 by 2 P1 is 0.2 1600 plus 600 will get is equal to 1 by 2 0.1 into 400 plus 150 plus 0.1 into 10 H2. So H2 is equal to, finally we'll get 590 meter is the answer we'll get. So in the above options, option B, we have got the velocity of the gas in end of the chimney is 40 meter per second and the upper end is 20 meter per second. That answer we got. The height of the chimney is 590 meter. This also we have got. So therefore both option B and option C are correct for question number 11. Okay, so now moving on to our next question, that is question number 12. Okay, so next question, that is question number 12. Here they are asked three plane mirrors, it form an equilateral triangle with each side of length. Its length is L. And there is a small hole of distance I, that is greater than 0, from one of the corners that are shown in the figure. A ray of light is passed through the hole. A ray of light it is passed through the hole at the angle theta, at an angle theta, and can only come out through the same hole, and it can only come out through that same hole only. The cross section of the mirror configuration and the ray of light lie on the same plane. So the cross section of the mirror configuration and the ray of light, it both lies on the same plane. So which of the following statements that they are given is correct, they have asked. That is, the statement that they are given is the ray of light will come out for theta is equal to 30 degree, for 0 greater than 0 is less than L, capital L. There is an angle for I is equal to L by 2 at which the ray of light will come out after 2 reflections. The ray of light will never come out for theta is equal to 60 degree and I is equal to L by 3, or the ray of light will come out for theta that is equal to 60 degree, and 0 is smaller than L by 2 after 6 reflection. So this is the diagram we'll get. Okay, so here in this diagram, if you see theta is equal to 30 degree, the ray will incident normally and hence it will retrace its path. So it will get incident and again it will come back to its path. So first option is correct. Now considering the symmetry of the situation, symmetric, if we consider it is also correct, so B is also correct. Now if we take the next C option, the ray of light will never come out for theta is equal to 60 degree. So theta is equal to 60 degree, but the ray will come out. It is not a problem. So therefore, in the above diagram, we can see that ray is coming out. Yeah, so therefore, C option is not correct. And indeed, they have asked as a clear from the above diagram. This diagram we can that is used for option C. If you see that, you can clearly understand total number of reflections, that is 5. So here D is also not correct. That they are given is the ray will come out of theta is equal to 60, but total number of reflection is 6 they are given. So therefore option D is not correct. So therefore the correct answer is option A, and option B is correct answer for question number 12. Moving on to our next question, that is question number 13. Okay, here they are asked 6 changes are placed around a regular hexagon of side length A, that is shown in this figure. Hexagon side length A, there see there are 6 charges, sorry, changes, not 6 charges are there. You can see 1 2 3 4, sorry, 1 2 3 4 5 6, yes, yes, one charge is unknown, but it is 6 charges. 5 of them have charge q, 5 of them have charge q, you can see, and remaining one charge, it has x value. We have to find it. The perpendicular from each charge to the nearest hexagon side passes through the center O of the hexagon and is bisected by the side. So the in above this, which of the following statements are correct in SI unit, they have asked. So when x is equal to q, the magnitude of the electric field is at O is 0. They have asked option A. Option B, when x is equal to minus q, the magnitude of the electric field at O is q by 6 pi mu OA square. When x is equal to 2q, the potential of, okay, so on it, yes, okay. So option D, the again is when x is equal to minus 3q, the potential at O is minus 3q by 4 to the power, 4 root 3 by mu A. So when x is equal to q, the situation, it is symmetric. So electric field at O would be 0. So therefore A is correct. When x is equal to minus q, we can think of x as, let us take x as q plus minus 2q. That is the magnitude of the electric field. At O is equal to 1 by 4 pi E naught into 2q by 2 into root 3a by 2 into whole square by 2 whole square. 1 by 4 pi E naught into 2q by 3a square, that is equal to q by 6 pi E naught a square. So B is also correct here. For x is equal to 2q, potential at O is V naught is equal to 6 into 1 by 4 pi E naught into q by root 3a plus 1 by 4 pi into E naught into q by root 3a. So 7q by 4 root 3 pi E naught a. It is correct formula. Now for x is equal to minus 3q, V naught is equal to 2 into 1 by 4 pi E0 into q by root 3a is equal to q by 2 into root 3 pi E naught a. So D is not correct answer. So therefore option A, B and C are correct, but option D is wrong. So therefore A, B, C is answer for question number 13. So we're moving on to our next question, that is question number 14. Here they have asked the binding energy of the nucleon in a nucleus can be affected by the pairwise Coulomb repulsion. We have to assume that all nucleons are uniformly distributed inside the nucleus, and the binding energy of the proton be EBP, and the binding energy of the neutron, let it be ENB in the nucleus. So which of the following statements are correct, they have asked. That is EBP minus EBN is proportional to Z into Z minus 1, where Z is the atomic number of the nucleus, or EPB minus EBN is proportional to A by A minus 1 by 3, where A is the mass number of the nucleus. Or option C, EP e to the power P by EB to the power P is equal to, minus EB to the power N is positive. EB to the power P increases if the nucleus undergoes the beta decay emitting a position. Now, the total binding energy without considering repulsion, that is EB is equal to ZMP plus A minus ZMN minus MX into C square is the formula we use for finding the binding energy, where into AZ into X is the nuclei under consideration. Now considering the repulsion, the number of proton pairs is ZC2 is the proton Z2 is the proton pair. Now repulsion energy is Z into Z minus 1 by 2 into 1 by 4 pi E0 E square by R, where R is the radius of the nucleus. EPB minus ENB, this formula if you use, there will be no repulsion term for neutron. Now R is equal to R naught A to the power 1 by 3. EPB minus ENB A minus 1 by 3. Because of repulsion among the protons, EPB is smaller than EBN. So therefore, since P plus decay, number of proton will be increasing, repulsion would decrease. So therefore, EP to the power P, it will be increasing. So therefore, option A, option B, and option D are correct. But EB to the power P minus EB to the power N, it is not positive. So therefore, A, B, D is answer for question number 14. Okay, now moving on to our next section, that is section 3. Here we have to answer. Section 3 has 4 matching list sets. Each set has one multiple choice question. Each set has 2 sets, that is list 1 and list 2. List 1 has 4 entities, so it is like multiple choice question, and correct answer will be 3 marks, 0 marks for no options, and negative mark for -1 in all other cases if it is answer is wrong. Okay, so now minute. Okay, so 1 minute.